Alright, so you were hopefully with me on that last video for doing order of operations with real numbers. We're going to continue on here with the example that you're supposed to try on your own. If you're just now tuning in, maybe you should try this one on your own to see how you're doing, and then stay tuned for my answer to that. Okay, so the first thing we're going to do here is look at order of operations. We have multiplication, subtraction, and addition. So I'm going to change this subtraction to an addition by saying add the opposite of the next number. And then I look at, okay, I have multiplication and additions. Well, multiplication comes first. So I'm going to put the whole number over 1 and I'll multiply straight across the numerators, giving me 3, straight across the denominators, giving me 2. And then I'm going to do some commutative property, even though that's not order of operations, just because I want to make this as easy on myself as possible. And so I'm going to put the two positive numbers together and I'm going to deal with them, and then I'll deal with this negative number over here. So 2 and 3, the common denominator is 6. So I'm going to build the higher term to 6. Now if I notice here, this one's a 6 too, so I could just go ahead and, what did I do there? That's not right. I could just build these across the board to a common denominator of 6, but as I've mentioned before, I don't like to do that personally because sometimes I find I waste my time. So I'm not as apt to just go straight across with all of the terms in an addition problem or an integer or an order of operations problem and just automatically add them up or build the higher terms. So I'm just going to go ahead and do this. So now I see that I'm going to have 6 and I'm going to add these two. So I have 3 times 3, which is 9, and I have 2 times 1, which is 2. So I'm going to add the numerators, 2 plus 9, which is 11. And then plus, and then I have this negative 1/3. Now I see, well, absolutely, I need to have the common terms. This is not going to reduce, so it's not going to make my life any easier. So I'm just going to go ahead and build this one as well to that higher term. So now what I have is a positive number and a negative number. We're over this common denominator of 6, so I'll just write that down. And now I have the big number, which is 11, and I'm going to subtract the smaller number, which is 2. And when it's all said and done, this is going to be a positive number since how 11 is bigger than negative 2. And so we have 11 minus 2, which is 9, and that's over 6. Now the first thing that glares at me is this is not in lowest terms. These both have a 3 in common. So I'm going to take out the common factor of a 3. So 9 divided by 3, which is 3, and 6 divided by 3, which is 2. Now the next thing that strikes me is 3 over 2. That's an improper fraction. So I'm going to make that into a mixed number. 2 will go into 3 one time with 1 left over, and that then goes over the original denominator of a 2. And so there's my mixed number. Now moving on, we're going to throw in our expressions into this whole thing. So the first thing I'm going to do in this problem, which is an expression, which also calls an order of operations for us, I'm going to make everything into an addition problem. So this subtraction plus and then the negative 5, and then plus and then the negative 9. So now I want to get the variables together. So I have a negative 3x and then a plus a 2x. And I'm going to put some parentheses around that to call it out, and then plus, and then I have a negative 5, and then plus a negative 9, and again put some parentheses around that to call it out. Now I have one term here and one term here that needs to get simplified to a single number. So I have a negative 3 and a positive 2. Well, negative 3 and positive 2, right? The 3 is larger, subtract the smaller one, the 2, keep the common sign, and then these things are x's. They're just my name. So this is a negative 1x. And then plus, and now I'm going to do the numbers. So we have negative 5 and a negative 9. So they're both the same signs, right? So I'm going to add those same signed numbers and keep their common sign. So 5 plus 9, which is 14, and then this is a negative 14. Now as a basic math student, this is a perfectly acceptable answer. I could box that and go that's perfect. But as we get a little bit more advanced, first of all, a lot of times we won't see a 1 out there. We'll just see a negative x. And second of all, we don't like to see this plus and negative. Remember that plus and negative is the same thing as subtraction, so we'll work that backward a little bit and say minus 14. So the way we like to see this written is negative x subtract 14. And that's the way we see it as we get to be algebra students. All right, the next problem here, this says the opposite of what's in here, and then plus 3x, and then plus that negative 9. So let's first of all work on inside the parentheses. Well, again, let's change this to addition, right? Plus a negative 9. So I have a positive and a negative number. So we're going to take the bigger number 9, subtract the smaller number 2, and we're going to keep the sign of the bigger one. The 9's bigger, so it's negative. And so now we have a negative 7. And remember, those are x's, right? Their names were x's, so it's a negative 7x. But this says we want the opposite of that. So that's a positive 7x. And then we have plus 3x, and then plus a negative 9. So now you see that these two are like terms, the 7 and the 3x's. So now that's just a basic math problem, right? 7 of those plus 3 of those. How many of those x's are there? There are 10 x's. And then we have plus the negative 9. Now that's a perfectly acceptable answer, but as we get more advanced, we like to see it not as 10x plus negative 9, but backing it out again as 10 subtract 9, because remember, plus and negative, that came from being subtract a positive number, so that's what we have, and that's our other option. All right, now let's see if you can do that on your own. So you just shut down the video and try this on your own and see how you do, and then you can come back and check your answer and see if you've gotten it correct. All right, so the first thing I'm going to do is I'm going to look in here and I'm going to say, okay, parentheses are going to come first. I've got a negative number and a positive number. So the larger is 3, the smaller is 2, and that larger number is negative. So this is 3 minus 2, which is 1, so it's a negative 1, and those things are x's. Now remember, this says the opposite, because remember this is plus a minus something. So that's the opposite of that number. This one's kind of tricky. So this says now negative 5x, and then plus, and then the opposite of a negative is a positive, so that's a positive 1x, and then we have plus a negative 5, or if you just wanted to leave that as subtract 5, that's okay too. And then the negative 5 and the positive 1, those are like terms. So again, this is a negative number and this is a positive number, so they're opposite. So we're going to take the big one minus the small one and keep the sign of the bigger. So now we have a negative 4, and those are x's. And then you can write that as plus a negative 5. That's perfectly acceptable. Or what we like to see even better as we get to be algebra students is backing it out to a subtraction problem. Negative 4x subtract 5, because plus a negative, that came from being subtracting a positive. So minus 5. All right, and that's our final problem at this point in time. So hopefully you're starting to get the hang of working with integers and order of operations and fractions and order of operations and even the real numbers, putting a sign with those fractions. And what I want you to remember, especially with working with fractions and having them have signs, is it's really just their numerators that have the signs, right? As you manipulate those numerators, then you follow the rules for adding and subtracting integers on the numerator portion of a fraction. And that should help you a lot with those processes.